In this example, we're given a probability distribution for the cash prizes of a lottery, including their individual probabilities. Looking at the example, because there are so many digits involved for accuracy, I'm going to choose to use StatCrunch. If there hadn't been such large numbers of digits here, I may have turned to my calculator instead because it's not a very long list. But just wanted to give you a heads up about why I'm choosing StatCrunch. So let's open up this table in StatCrunch. The first thing that we're asked to do is find and interpret the expected value given that the grand prize is $13 million. Now notice that, again, in the table it didn't say that. I'll slide that over just for a second. It just put the words grand prize. So if you are using another technology, you want to type in right here 13 million. But StatCrunch already has that for us. So the next thing I want to do is find the products of each individual cash prize and its corresponding probability. So to do so, let's go to Data, Compute, and Expression. I'm going to build the expression. So if you click on that button, it takes you to the column names. This way I don't mistype anything. You can either click on it and click Add Column, or you can double click that spot. And notice that it's added the column name and it's already included the quotations like we need it to be here to operate in StatCrunch. Again, we're taking those cash prizes and multiplying by the probabilities. And then from there, let's click OK. You can give it a label. If you don't have these labels already in here, you just type it in, whatever you want to call it. I'm going to call it product and then compute. And it's automatically computed those products for us. So the next part of expected value is to find a sum of these products. So I just want a sum of this particular list. So now I'm going to go to Stat, Summary Statistics, Columns. I'm going to select Product, and I just want the sum. That's the only statistic that I want here. And then I'll compute, and I get the following sum. That is the expected value. So you'll see that over here. That's the expected value, 0.30 when rounded to the nearest cent. As far as interpreting that, what that means is that on average, you should expect to win 30 cents per lottery ticket. And we say here win because that's a positive expected value. Now, but when we account for paying some money to play the lottery, and that's what's given here in this next part, let's assume that we have to pay to play, right? We're going to pay $1 per ticket. Now what we have to do is consider that as part of our payout. And if we do 1 minus the 30 cents that we win, $1 for what we paid, sorry, I probably should say that the other way, technically. The 30 cents that we win minus the $1 that we paid, because that's coming out, we have a negative value. So that's a negative 70 cents. So that one can be interpreted as if you're paying $1 per ticket, then you are losing 70 cents per play per ticket. Again, because of the negative sign there. The next part asks that to the nearest million, how much should the grand prize be so that you can expect a profit? For this one, I'm going to get a little creative here with StatCrunch. So what I'm going to do is I'm going to select just these values. Remember, these do not contain the grand prize product. I'm going to copy them by using Control-C and then paste them by using Control-V into the next column. And now I want a sum of just this column. If I were not using StatCrunch, I'd probably just add up these remaining values, not the first one. Because again, I want to try to work backwards to find what that cash prize should be so that I have a profit. I'm going to do the same kind of summary statistics. I'm going to go back to stat, summary stats, columns. This time I'll select var 4 for the name of that column. I didn't name anything special. Sum, and then compute. So keep that number in mind, 0.208 approximately. Actually, I think what I did was just copy and pasted it because from here, I just brought up an online calculator. It's not a very complex calculation or anything. So what I did was I wanted to subtract that from 1. What I'm trying to find is the product that's needed here so that when I sum everything together, I get a value of 1. So here's the needed product. I'm going to take that number, and I might be able to copy and paste this too. Let me try that. Sure enough, it worked. All right. And then divide by the probability that's associated with the grand prize. So let me go back to the example. The probability that's associated with that is this number. I think that's 8 zeros after the decimal, if I counted correctly before. And here I have, this needs to be the payout for the grand prize in order to get a profit from the lottery. So remember, we have to pay $1 to play. So that's why, again, I was subtracting my probabilities up here from 1. And I want what's remaining to account for that difference. So I think in my math lab, it does ask us to round to the nearest million. Be careful about that. So I just have to count off here to the nearest million. That means I'm rounding to that digit right there. The 0, the 5 rounds that up. So that's 111 million. There's one remaining question. Does the size of the grand prize affect your chance of winning? It does not. The size of the grand prize only affects your expected value or your payout. You call it like that. The chances of winning are already predetermined, and they are expressed here in this probability distribution.